Hello, welcome to Astronautics for Exploit. This is Dr. Ayonshola Ogundele. Use cases of satellite ground segment virtualization, demonstration of the NewSpace cost-effective ways of scaling operations. Based on various technological evolution, low Earth orbit constellations, large groups of satellites in low Earth orbit that work together for global coverage, and software-defined spacecraft that use onboard software to dynamically adjust the functions, enabling flexibility and upgrades over time, are converging to provide flexible, real-time control needed to manage thousands of moving satellites in a low Earth orbit constellation. Unlike single, expensive, and large geostationary satellites, which have a more limited view, low Earth orbit constellations, based on their cost effectiveness and ability to provide a network for communication, observation, and other services, are being used to provide continuous and global coverage. Example is Starlink, which consists of thousands of small satellites working together to provide communication services. The software-defined satellites provide advanced control necessary for managing the complex networks of low Earth orbit constellations, optimizing performance and adding new capabilities. Virtualization of the satellite ground segment involving movement from traditional hardware functions, such as modems and processors, into software running on generic off-the-shelf servers has various use cases. And examples are scaling satellite constellations, Earth observation and remote sensing, flexible satellite communications, resilience, and disaster recovery. The focus points are as follows: virtualization use cases and use cases of satellite ground segment virtualization. Virtualization use cases. Virtualization of the satellite ground segment involves moving traditional hardware functions such as modems and processors into software running on generic off-the-shelf servers. By shifting from physical infrastructure to cloud-based solutions, organizations can enhance scalability, flexibility, and efficiency. The picture here illustrates Galileo ground segment. Application of virtualization includes server consolidation in data centers, developing and testing software across multiple platforms, providing remote and secure access to applications for users in various sectors such as healthcare and education, and streamlining software deployment and updates. Copernicus ground segment is illustrated in this picture. Use cases of satellite ground segment virtualizations are as follows: scaling satellite constellations, Earth observation and remote sensing, flexible satellite communications, resilience and disaster recovery, development and testing, remote and hybrid operations, mission control and command automation, hybrid and distributed operations, and network integration with 5G. Each of the use cases is described as follows. Scaling satellite constellations. For large and rapidly expanding satellite constellations, such as low Earth orbit constellation, a virtualized ground segment offers a flexible solution for mission and data management. Dynamic resource allocation. Operators can instantly scale their ground segment resources up or down in order to match communication demands. This is especially useful for constellations with thousands of satellites that produce vast amounts of data. Ground data systems and mission operations is illustrated in this picture. Economies of scale. Rather than building and maintaining dedicated hardware for each new satellite, operators can use shared virtualized resources. And efficient path scheduling. Virtualization enables a multi-mission ground station model where a single antenna can service different satellites at the pass over the horizon. Select ground segment facilities worldwide is illustrated in this picture. Earth observation and remote sensing. Virtualization is transforming how Earth observation data is processed and distributed, drastically reducing the time from data collection to analysis. Rapid data transformation. After a ground station receives a raw satellite payload telemetry signal, digitized as close to the antenna as possible, the virtualized ground segment can quickly process and transform the data into a usable product, such as an image. Network topology of a satellite command and control system is shown in this picture. Accelerated delivery. The processed data is immediately delivered to cloud services for analysis, analytics, storage, and distribution to end users. For example, a system can use machine learning to automatically detect and track wildfires, alerting first responders much faster than manual methods. Integrated ground system is illustrated in this picture. Flexible satellite communications. Traditional satellite communication networks rely on dedicated hardware, which is difficult and costly to adapt. Virtualization enables a more dynamic and responsive network that can be reconfigured in software. Seasonal and special event traffic. For applications with fluctuating demand, such as cruise ships or major sporting events, virtualization allows operators to provide extra bandwidth. Control center at NASA Jet Propulsion Lab is illustrated in this picture. Network convergence with 5G. Virtualization is very critical for integrating satellite networks with terrestrial 5G infrastructure. Using a cloud-native software-based architecture, satellite systems can be seamlessly orchestrated with 5G networks. NewSpace ground segment is illustrated in this picture. Hybrid and distributed operations is another use case of satellite ground segment virtualization. Virtualization offers a flexible architecture which can blend physical and virtual components to enhance reliability and leverage cloud capabilities. Critical functions can be run on on-premise hardware, while less critical or high-volume functions are virtualized in the cloud. Satellite ground station is illustrated in this picture. Hybrid deployment. A satellite network can be controlled via a hybrid approach using a mix of on-premise and cloud gateways, routing traffic to the most efficient option, and this provides operators with greater flexibility and control over their assets. Australia's fleet of Internet of Things SATCOM ground station is shown in this picture. Mission control and command automation is another use case of satellite ground segment virtualization. Virtualization makes mission control more intelligent and less resource intensive by enabling automation and modernizing the software infrastructure. Mock-in-the-box solutions. For small startups, universities or smaller scale missions, virtualized mission operation centers provide all the necessary command and control telemetry and data management. Leo satellite constellations, Starlink, OneWeb, Upcom, and Iridium is illustrated in this picture. Mission planning. Cloud-based mission planning and orchestration tools can run in the cloud, and these allow operators to rapidly submit and analyze acquisition tasks for entire satellite constellations. This capability can also prioritize urgent tasks, such as for disaster relief. Enhanced visualization. Virtualized ground systems can be integrated with advanced artificial intelligence and machine learning tools for real-time monitoring and advanced data visualization. Low Earth orbit constellation is illustrated in this picture. Resilience and disaster recovery is another use case of satellite ground segment virtualization. For mission-critical applications, virtualization provides a reliable, geographically dispersed backup option. System redundancy. A hybrid model using a virtualized ground segment offers an immediate backup solution in case a physical on-premise ground station experiences an outage. Gateway diversity. Satellite operators can use a mix of on-premise and cloud gateways, routing traffic to the most efficient and cost-effective option while ensuring connectivity. Galileo ground segment is illustrated in this picture. Development and testing is another use case of satellite ground segment virtualization. Virtualization provides an efficient and low-cost environment for innovation and research. Developers can use cloud-based environments in order to spin up and tear down virtual test networks quickly. Digital twin system is illustrated. Virtualization gives operators greater flexibility in managing their networks from anywhere and helps remote and hybrid operations. Decentralized command and control. A virtualized system allows operators and engineers to manage mission control from a laptop, enabling hosted anywhere flexibility. Hybrid deployment for sensitive or high priority traffic. Operators can maintain on-premise hardware while moving lower priority. Ground system architecture is illustrated in this picture. Network integration with 5G. For satellite communication providers, virtualization is key to integrating satellite networks with terrestrial 5G infrastructure. Seamless orchestration by using a cloud-native software-based architecture, satellite systems can be seamlessly orchestrated with 5G networks in order to provide expanded coverage. Traditional versus ground station as a service model is illustrated in this picture. For more information, contact Astronautics for Exploit. You've been listening to Use Cases of Satellite Ground Segment Virtualization, demonstration of the NewSpace cost-effective ways of scaling operations by Dr. Ayoshola Ogunlele, with a focus point, virtualization use cases and use cases of satellite ground segment virtualization. Thank you.